Hi, I'm Krishna. This is day 10 of 30 days of understanding the modern AI stack. So in this video, we're breaking down the architecture that replaced everything before it, transformers. So here's a crazy thought. Every large language model you have ever used, Gemini, GPT, Claude, they all run on one idea. Every token can look at every other token at the same time. No waiting, no recurrence, no memory problems. Just pure parallel intelligence. But why do transformers even exist? Before transformers, we had RNNs and LSTMs. They read text one token at a time, like an old man reading a newspaper. Slow, forgetful, easily confused by long sentences. Transformers solve this by removing recurrence entirely. Instead of processing token by token, the transformer says, you know what? Let me look at the whole sentence in one shot. And here comes the heart of everything, self attention. It's simple. Every token gets to ask every other token, how relevant are you to me? For example, the sentence we have is, I unlocked my phone because it was ringing. Self attention helps the model figure out that it refers to phone, not I. This is why transformers understand context better than anything before that. And the only math we must understand is that every token becomes three vectors: query, what I am looking for; key, what I contain; V, value, what information to share. And the formula for attention becomes this. That's it. One formula powers the whole field of modern NLP. But why we divide by square root of D, which is the dimension of query key vectors? Actually, it's the scaling trick. If your vectors are big, dot products explode, softmax saturates, gradients die, model collapses. So transformers add this tiny trick. Divide by square root of D. This keeps the numbers calm and the learning stable. But stability alone is not enough. Transformers also need flexibility. And that's where the next part comes in. Multi-head attention. One attention head, one perspective. Multiple heads, multiple perspectives. Examples of what different heads learn: subject, verb, names, pronouns, adjective, noun, long range references, numbers, dates, units. It's like giving the model multiple pairs of eyes, peripheral vision. After attention, each token goes through a mini multilayer perceptron. Linear, GALU, linear. Attention decides who to look at, and feed forward network decides what to do with that information. But we still do have a problem that the outputs of this attention and feed forward networks are chaotic, for which we use a LayerNorm, which calms everything down, and residual connections, which make sure gradients don't vanish. These two tiny tricks are why transformers can stack 12, 24, 96, and even more layers without collapsing. So a transformer block is basically a normalize, attention, add, normalize, feed forward network, add, and then you stack a bunch of these. This is the engine behind GPT and every model you have ever used. And here's the kicker. Why you need to understand this? If you want to build real AI systems like RAG pipelines, agents, evaluators, AI tools, you don't need every formula from the paper. The attention is all you need. You just need to understand how attention compares tokens, why query key value exists, why multi-head attention gives depth, why transformers scale infinitely better than RNNs, and how the architecture keeps itself stable. This mental model is enough to build anything modern. Transformers aren't magic, they are just parallel attention, residuals, layer norm, and a few clever scaling trick. In the next video, we'll go into positional embeddings and masking. Without it, we can't differentiate, the model can't differentiate between I eat apple and apple eat me. They are both identical without it. See you in the next video. Let's do it.